All right, let's start today's lecture. So this is today's outline. So first we will go through some announcements, and then let's have a look at the roadmap of what we will be learning in the next 2 weeks. And let's have a quick recap of what we have learned on Monday. And then Dylan will show you the database that is to be used for assignment 1. And after that, we will learn 2 new concepts. And the first one is wheels in SQL, and the second one is multi-table query. So the first announcement is that quiz 2, the due date of quiz 2 is midnight tomorrow. So what I suggest is you just do it, because even if you randomly choose even if you randomly choose make your choice for the questions, you can there's a very low chance for you to get a 0 mark. So just do it, And for assignment 1, it will be released by this weekend. And the submission date is before the end of week 5. So you will have 2 weeks for finishing assignment 1. And we will go through the database to be used in this assignment later. And basically it will cover SQL wheels, SQL functions, and PG SQL functions. So you can use whatever means you'd like to finish this assignment. But I hope you can do it on your own. And I don't know if you play games or not, but I don't want your university life to be just like playing a survival game or even a horror game. Let's not do that. And I hope your university life should be like a hack and slash game. So whenever coursework comes, you just slash them. All right. So I hope you can finish the assignment with whatever means you like, but I hope that you could do it on your own. That's what I hope. And that's for assignment 1. And the third announcement is that we will be hosting some help sessions in next week. So you can ask, some tutors will be attending these sessions to help you out. And during the help sessions, you can ask anything you would like to ask. Like for example, you can ask for the answers to tutorials. You can ask for specifications or clarifications for assignment 1. But you can't ask for answers to the assignment. And now let's have a look at roadmap and recap. So in our last lecture, we have covered the statements for doing data modifications. Oops. And the first type of statement for doing data modification is called insertion. So remember that we have 3 different styles of insertion. So the first style is that we could insert into a relation. We just specify the name of the relation, and we can insert a row into that relation. So that's the first style. The second style allows us to specify the attributes after the name of the relation. So in that case, we don't need to follow the order of the schema definition. The attributes to be inserted doesn't need to follow that order. And we can selectively use the attributes to be inserted. And the third style allows us to insert multiple rows at once with one statement. So that's what we can do. And although we can use the third style to insert multiple rows with one single statement, in practice, it's often the bulk insertion is also needed because sometimes we need to insert data from other files, from other programs, or even from standard in. So do remember that Postgres allows us to do bulk insertion. And the command related to bulk insertion is called copy. So that's about insertion. And for deletion, so we can specify the table we would like to delete from, and we can use a where clause to filter the data we would like to delete. And there are two types of logic for implementing this deletion mechanism. So can you still remember what are the two types of semantics? So actually the answer is in the parentheses here. So the first one is we can iterate through the table and delete the row one by one. So once we meet a row that fulfills the conditions, that met the conditions we have specified, we can remove that row from the table. So that's the first type of implementation. The second type of implementation is that we use two loops. So in the first loop, we just take note of the tuples that could meet the requirement or the condition. And in the second loop, we just remove all the rows we have taken note of. So we have experimented in our last lecture that Postgres is actually using the second type of implementation. And do remember that what's the difference between the first and the second type of deletion implementation. So in most of the time they are the same, but there are, in certain corner cases, the second type of deletion implementation will delete more data from the table. So that's about deletion. And we also learned about update. So the basic syntax for update is that we update a table and set a list of assignments, and which can be followed by a where clause to indicate the data we would like to update. So this is about update. And for those statements which include where clause, so what's the default? Can you still remember what's the default behavior of not having a where clause? So does it equal to where true or does it equal to where false? So if we don't specify the where clause, it's where true. So the statement will be applied to all the rows or all the tuples in the table. So that's about the default behavior. And in our last lecture, we have also covered the single table queries. So here are some features provided by SQL for doing queries. So the first one is filtering. So we can use where conditions to filter the data we would like to fetch or retrieve. The second one is combining. We can combine data from different tables, and this will be covered later in this lecture. And we can do summarization. So the summarization is done through aggregation operators, which are applied to columns of data. For example, we can calculate the sum of a column of numbers. We can calculate the average of a column of numbers. We can also count the number of items with the count operator. So this is about summarizing. And there are also set operators that could be applied to the query results. And this will be covered later in our class. And another feature provided by SQL is grouping. We can group tuples according to certain attributes. And do you still remember how should we filter groups? How should we apply constraints to groups? What's the keyword here? The keyword here to use is having. So we use the keyword having to filter groups. And we will cover, and SQL does allow us to define some custom group, so custom grouping mechanisms. So we will cover those features later. And the last feature that SQL allows us to do is that we could rename attributes when we do the queries. So that's what we have covered in our last lecture, and our plan here is we will be covering all major concepts to be used for assignment 1 by the end of week 4. And in week 5, we will use one lecture to summarize and discuss some of the details we have learned. And I will be discussing some discussing problems in that lecture as well, because I found that some students have posted some interesting questions on the forum, and I will spend some time to discuss those interesting ones. And in week 5, we will also spend one lecture to continue our learning journey. But that is not useful for completing your assignment 1. And in week 5, we don't have quizzes, so you can focus on your assignment 1. So compared with the course outline, we will be a bit ahead of the course outline. And this is to give you more time to finish assignment 1, and this is to avoid the case that where you learn something in week 5 and use it for assignment 1, so you don't have enough time to really digest the knowledge. So that's about the roadmap and recap, and I will invite Dylan to show you the database to be used in assignment 1.
So assignment 1 will be coming out very shortly. We plan on getting the database schema as well as the data available this evening for you to look at on the course website and download. And the questions, the actual questions of the assignment will be released hopefully tomorrow evening, Saturday at the latest. So database design, a little bit small, but hopefully that's legible, is based on IMDb, the Internet Movie Database. And the database design is taken directly from their own database download. They actually provide a free available download of their data. So our database is based on their database design and is using the actual data from IMDb. There are a couple of changes to the database design. We haven't used their design exactly. We can see here, let's see, what have we got? So we've got our main entity, which is our movies entity. And we have our database schema. Again, you'll be able to look at this in your text editor with nice syntax highlighting. But our movies entity has some general information. We've got an ID to reference the movie. We've got the title of the movie. In fact, we've got 2 titles of the movie because there are many movies that are known by different names. So we've got 2 different types of titles. We've got the year of release, the runtime, and then a rating for that movie, as well as the number of votes cast in that rating, as well as some custom domains that have been created to help organize our database. So we've got a domain which is a counter, a domain which is the minutes, a domain for the year, and a domain for the rating. We have a couple of smaller entities for releases, which is a release is a movie that has been taken to the cinema in a particular part of the world. Releases may be in different languages or different regions of the world, and that data is available in the database. We've got our genres. Each movie has one or more genres available. If we go back to our ER diagram, we can see that our genres here are tagged with a end-to-end relationship. So each movie can have multiple genres. Each genre can be in multiple movies. And we also have people, which will be the actors who are acting in the movies, as well as the crew who are creating the movie. Here we go. So we've got some professions, which is someone's job. We've got the movie genres, which is our end-to-end relationship, mapping our movies to our genres. We have a table for people working jobs, the people professions table, people working their jobs. And we have the principals and the credits, which is the principals is a person who is well known for a particular movie, which simply is an end-to-end relationship linking a person to a movie, as well as credits, which are similar to principals. Credits also link a movie and a person together, but in this case we have additional information. In this case we get the job that the person had in the production of the movie, and if they were an actor or actress, we also get the character that they have played in that movie. So that's our database schema. Again, we can go back to our overview there to see our relations that we have. And as I said, that's just a brief overview. You'll be able to look at that in more detail this evening. I would highly recommend taking the time to open it up, play around with the database before you get your questions tomorrow or Saturday, and then you can start working on everything. All right.
Thank you, Dylan, for introducing the database. So the database we will be using is a real-world one from about the movies. So I hope you can find your favorite movie in the database. And
unfortunately, you don't get the entire thing because it's about 7 gigabytes. You get a small section of the database.
Yeah, if you have a broader interest in movies, you will find your favorite one inside. And now let's continue our main content of lecture today. So what we will be learning is wheels. So a wheel is like a virtual relation. This is to be used in our assignment 1. So a wheel is like a virtual relation defined via a query. So it is like a temporal storage for the result of a query. So this is wheel. And here are the command statements related to wheel definition and removal it is very similar to the statements used for table creation and removal. So we use create and drop for creating and removing views. And the difference here is that views are created based on queries. So we need to have, the syntax is like we create view, specify the view name, and use the keyword as to specify the query to generate that view. So that's the statements related to view. And we can also use create, the statement called create or replace to replace the query that is associated with an existing view. So that's the basic statements here. So the key characteristics about views are that the stored tables of views are referred to the base table. So a view is like a reference to the base table. So if you have learned about C, a view could be a view is corresponds to a pointer in C to the actual data. So that's how view works. And views are only defined after the base table has been defined. It relies on the existence of the base tables. And a view is valid only if the query for generating that view is valid. So if a query is not valid, or if that query runs into some errors, the view is not created. And dropping a view does not affect the base tables. So so let's use the example of C language. If you just delete a pointer, the actual data won't be affected. So that's the effect of dropping views. And views are, why do we have views? You can see that it's just a place to store the query results. So why do we have them? So the benefit of having views is that it allows you to store and package some complex queries. So sometimes you may have a very long query that uses multiple joins, multiple group bys, or even multiple aggregations. And you can store them as views. And views, since views are like virtual tables, you can actually apply those table query statements to views. So it allows you to, so it is kind of giving you the table, the intermediate table you want for a complex task. So if you are solving a problem in multiple steps, you can create a view as the intermediate step. So this is the benefit of using views. So as I just mentioned, views are like tables. They can be used in queries as if they are normal tables. However, the difference is that the values, there are two major differences between views and the actual tables. The first one is the view. The result of a view is changed whenever the base table is changed. So let's use the example of C language again. So if the actual data pointed by the pointer has been changed, so when we use the reference, the data we get is also changed. So that's the first thing. The second characteristic here is that views may not be explicitly modified. So there are some restrictions for updating views, the content of views, and we will go through the restrictions in our next few slides. And before we jump into more details, let's do an exercise. And if you have your if you have your own device with you, you can try to open up this one compiler page. And in this example here, we have one table, and this table is called hotel. And it has 4 characteristics. It has hotel ID, it has name, it has license, and address. So the hotel ID here is the primary key for the hotel table. So we have populated a few hotels into the table, and now let's go through the questions. So the first exercise is that how to create a view for name, license, where address is in Sydney or Melbourne. So how to create this view? So remember that the syntax here is create view and the name of followed by the name of the view as followed by a query. So the key here is the query. And the query we could use is what we have learned in our last lecture. It's a single table query. So what we can do is we can select name and license from hotel where address is Sydney or Melbourne. So how do we do that? So we have 2 choices for checking whether an address is in Sydney or Melbourne. So we can use the logic operator or. So we can use address equals to Sydney or address equals to Melbourne. So that's what we can do. Another choice here is we can use set. We can use set operators. So what we can do is we can say where address is in a set made up of Sydney and Melbourne. So this is essentially doing the same thing of using a logical OR here. And this looks clearer. So this is how we create a view. And remember that views could be treated as tables. So in order to see what's inside our just created or fresh created view, what we can do is we can select all the data from that view. So let's run this program. As you can see, we have stored all the hotels which are located in either in Melbourne or Sydney into our view, which is a temporary table. And now let's try to play with some of the mechanisms of views. So what will happen if we update the original table? What will happen? So say if we just append in seed into after the name of the hotel, if the hotel is in Sydney, and we will append in Mel if the hotel is in Melbourne, what will happen to our view here? Yes. The content of the view will be changed as well. So let's have a quick look at. So as you can see, if we update the data from, you notice that the view is created before we do the update. And if we update the content of the base table after even if after we create the view, and the view will be affected. So just remember, view is like holding a reference to the actual data. So it's like just the reference. And if the actual data changes, it will be affected. So that's the key mechanism here about views. And now let's continue. As we have just learned, views, explicit updates on views requires certain conditions to be met. It has some restrictions. So here are the 3 restrictions. And the first one is the view must be involving a single relation. The second one is the where clause does not involve a subquery. The third one is the where clause only uses the attributes from the select. And attributes not used in the select query for the creation of the view will be treated as null when we do insertion, if we want to insert something into the view. So it's just like when we create a view, we select some attributes, right? And if we insert something into that view, and the attributes for those attributes which are not involved in the creation of the view, they will be treated as null values. And let's see an example here. If you have your own laptop or your own device, you can follow you can follow this exercise. So we are using the same data table we used in our last example, and it's about cities and hotels. And we are creating exactly the same view as we just created. And let's go through the questions. So do you think this insert will work or not? Remember, why not? I see some of you are shaking your head. Why not? It's either yes or no, because it's not yes, so it's no, right? But the thing here is, remember, let's see the result first. So no is the correct answer here, and the error we got is that there are some it violates some not now constraint. The reason is because is because of the last piece of knowledge we have learned in our previous slide. It's because views, when we insert into views, the attributes which are not involved in the creation of that view will be treated as null value. So when we create the view, we select name, license, and address, but we don't select hotel ID. So hotel ID is the attribute that is not involved in the creation of the view. So it is treated as null value here. And remember, primary key indicates 2 properties, unique and not null. So null value is not allowed for primary keys. So that's why this insertion won't work. So that's the first example here. So let's do a small change to our insert statement. Let's try to insert this one into the view. Can we do this? Will this work? Will this one work? Let's see it in action. It also doesn't work because we are inserting as if we have an ID in the tuple we want to insert. However, for this view here, the first attribute involved in this view is called name, and if we insert 3 values into the view, the first attribute actually corresponds to name, and it is not stored in the ID column, so that's why it doesn't work. So what if we do another change? Let's say we add one more value to the tuple we want to insert. What will happen? Will this one work? Some of you are trying it, I think, and you are shaking your head. And it doesn't work as well. It's because when we define the view, we only have 3 values. We only have 3 values defined. So we cannot provide 4 values in the insertion. As you can see, all of the attempts have failed because updating view is a very restricted behavior. So all the 3 attributes or constraints must be satisfied for view to be updatable. So this is what you should keep in mind. Inserting into views is highly restricted. So let's move on to, since we can't insert into this view, let's try to change the view this time. So let's say we can't insert into the view, but what about actually changing the values inside the view? Can we do this update here? Will this one work? This update is actually the same as the update we have applied to the base table just now in our previous example. So will this one work? Oops. Actually, this one works. So as you can see, because we are not violating any of the constraints, we neither violate the not now constraint indicated by the primary key. We didn't violate the number constraint of attributes. So this one works. And as you can see, what we have selected is from the view. And what happens to the base table, to the data in base table? Will they be affected or not? Remember, deleting a view will not affect the original table. But what about updating the content of the view, changing the content of the view? Will it affect the original table? let's see. The answer is yes. So you can safely think of views as pointers in C. So if you update a value through a pointer, the actual content pointed by the pointer is changed. And if the actual content pointed by the pointer is changed, it is also reflected when you read data through that pointer. So if we update the view, if we update the content through a view, the base table will be affected. And if we delete a pointer, the original data is still there, it's not affected. So this is how view works. And another thing to take note of is that when we create views, there could be duplicate tuples or rows inside that view, because we are only if we don't select the primary key from the base table, there could be possibly a duplicate of data. So can we have specify a key like unique identifier for each row inside a view? Can we do that? Actually, views don't have primary keys, unlike tables. They are just virtual tables, and they don't actually store data. And we could have some alternatives, and that is called indexed views or materialized views. So which is to actually materialize this virtual table, which is to actually store the data held by the view onto our physical storage. And this allows the database managed system to do indexing as well, which could speed up the searching process. So this is an alternative for doing the virtual views. And here are some more information about materialized views. So materialized views are actually implemented by the DBMS as stored tables. So on each update to the base tables, the DBMS will need to also update the view table to make sure the data consistency. And this is, of course, this will cost you more space, but and it will also make the update operations more expensive because you are updating two different sources of data. However, it is useful because updates are often infrequent compared to queries of views, and since materialized views could be indexed, querying those materialized views is faster than querying the normal views. And sometimes the cost of computing a view could be expensive, especially when it involves thousands of or millions of lines of rows inside the table. So materialized view is actually spending some space in exchange for execution time. So this is the concepts about materialized views. And the command to create a materialized view in Postgres is just to add the keyword materialized after the create statement. And here are some information about how the two different types of views are actually implemented in DBMS. So for those virtual views, the implementation is using some rewriting rules. So whenever a view is used in a query, the DBMS will just rewrite that query as if it is performing that query on the base table of the view. So this is how DBMS implement the first type of view. For the second type of view, for materialized view, the view is actually stored as a view table in database, and DBMS will maintain the update consistency for it. And the difference is that the query, the underlying query applied to the view is either evaluated at query time or at update time. So for the virtual views, it's evaluated at the query time and it is rewritten. And for the materialized view is only evaluated at update time, because when we just read the data, we don't need to rewrite the data, the query. And here's an example, or here's the pseudocode or example of rewriting how DBMS will rewrite a query to a virtual view. So let's use the same example as we have used in our previous examples. So we can create a view, and if we select from that view, what DBMS actually does is to rewrite this select into a select from the base table of the view by manipulating the conditions. So it's like merging the conditions of the creation of the view and the query used here on the view. So this is how it is implemented. And that's all about the first half of today's lecture. And let's have a 10 minutes break. And you can grab some snacks here. Actually, I see some confusing faces in today's lecture because you will need to practice. You will need to try out the examples on the slides. So to be clear about all the concepts and differences between the mechanisms. All right. Before we start, let me share you an interesting fact about this type of biscuits. And recently, I read an article about the magic behind the creation of these biscuits. So you know why it makes you feel like eating one more pack after you finished one pack. So you know why there are two pieces for each pack. There's not one piece, just one piece per pack. Why they put two pieces inside each pack. Actually, the magic here is that they intentionally make the level of saltiness per piece different. So one piece tastes stronger, the other one tastes weaker. So when you eat, you feel the change of flavor. So that's why it makes people addictive to this kind of biscuits. And that's why they put two pieces per pack. So that's the magic behind. And it's not to save the packaging fee to not just put one piece per pack. So that's some interesting fact. And let's continue our lecture today. So what we will learn is multi-table queries. So the queries involving multiple tables. So as we have learned, we can do a lot of things by querying just a single table. We can do groups. We can apply aggregation operators. However, that's not enough. And if we want to exploit all data in a database system, we need to be able to combine data from multiple tables. And we also need, this typically involves matching the primary or foreign keys, because tables are connected by foreign keys. And the keyword for doing multi-table query here is called join. So join is the SQL operator that combines tuples from tables. So it's the operator to concatenate two tuples or multiple tuples. So this is the keyword join, and it is a very, very important operation. And it has a lot of variations which could be confusing. And according to the operator we use for doing the join, for joining two tuples, we can categorize joins as equi-join, which is to match tuples via equality checks on specific attributes. For example, if we want to append the tuple of an employee with a tuple from the table of contact, what we can do is we can check for the equality of family names. So if we want to append a tuple of an employee with a tuple from the contact with the same family name. So this is the first type of join. And the second type of join is theta join. It is used to match tuples via Boolean expressions. So this Boolean expression could be different from just an equality check. It could be used for, you can use any operators here, as far as it produces a Boolean value. And according to result, there are many more different types of joins. The first type of join is called inner join. It will, if we join two tables together, it will return the table. We will return the tuple when there are exact matches in both tables. So this is inner join. And for left outer join, it returns all rows from the left table plus the matched rows on both sides. And even if there are no matches from the right table, it will still return all the rows from the left table. So this is called left join. And the third one is called right join. So in comparison with left join, the concept is very similar. So it will return the matched rows plus all the rows from the right-hand side. And even if there are no matches in the left table, it will return all the rows from the right table. So this is called right join. And the full join, which is also an outer join called full outer join, it is used to combine the results of both left and right tables. So the join table will the join table will contain all the data, and if there's no match, the attributes of the other table will be filled up with null values. As you can see, we have 3 different types of outer joins, and we have 1 type of inner join, or just join. So we can omit the keyword outer here when we actually write the commands. And this looks very, there's a lot of words here, and there's a lot of concepts here. To help you better memorize the difference, we can use this illustration. So for inner join, it's very straightforward. We just return the rows that matches in both tables. And for left join, so all the content of the left table is also returned. For right join, all the contents of the right table is also returned. For full outer join, is if you just follow the pattern here, is very straightforward as well. And for inner join or full outer joins, the order of table in that statement doesn't matter. However, for left or right joins, since we have a direction, the order matters. Let's have an example to help you understand the concept here. So assume the first picture corresponds to left join. So what does the second picture correspond to? The second one actually corresponds to right join. And what about the third one? The third one is inner join because it results in the least amount of data. And of course, the last one is full outer join. And that's about the concept of joining tables or tuples. And the syntax for writing join statements is in SQL is like this. You can select, it's used in select queries. You can select attributes from the first relation, join second relation on some condition. So if we don't provide this condition, joining condition here, it is like a Cartesian product, which is to provide a permutation of all the possibilities of combining 2 tables together. So however, if we use this on condition here, we can specify how do we append or how do we attach one tuple to another one. So followed by the first join, we can have the second or third joins. So we can join multiple tables. And the where clause, we can also, like the normal select, we can also use the where clause to filter out some of the joined tuples. So the where clause is applied to the result of the final tuple. So there's an alternative syntax for writing joins in select queries. So instead of writing all the joins there, we can just use a comma to indicate inner join. So, but unfortunately for left or right join, we cannot use this notation. So what we can do is we can select from two tables, and if we connect them with comma, it means those two tables are joined together using an inner join, and then we can apply some where conditions. And in this set of slides, we prefer to use the explicit join syntax, but sometimes we can also use this alternative choice. So let's do some exercise to see how join works. You can do it on your own laptop, and since we are dealing with queries on multiple tables, so in this example we have two tables. So the first one is called department. It has two properties, and the first attribute is department ID, which is used as the primary key, and the second attribute is department name. And for employee, we have three attributes. The first one is called employee ID. The second one is employee name, and the third one is belongs to. So let's have a quick recall of how we map ER diagrams into SQL schemas. So what's the relationship between employees and department? It's actually a one-to-many relationship. So the hidden relationship here is belongs to, and we don't need a separate table in this case because it's a one-to-many. We can safely store the relationship as an attribute on the many side, because the quantity of the relationships totally depends on the number of the many side entities. So that's why we can put the relationship belongs to as an attribute in the employees table, the many side. So many employees can work in the department. One department can have many employees, but an employee can only work for one department. So after we populate some, so here are the commands to populate data into the tables, and let's move on to the questions here. So the first one is find out all employees who belong to a department and their associated department names. As you can see here, some department, for example, computer science and engineering, they don't have any employees belonging to computer science and engineering, so it's an empty department in this example. And for some employees, they are not belonging to any department. So the first question is find out all employees who belong to a department and their associated department. So which type of join should we use? As you can see, we need data from two tables. we need the name of the employee. We also need the name of the department. And we need to find out those who are the employees and department which are involved in the belonging to relationship. So which type of join should we use here? You can just make a guess. There are only 4 choices. Actually, since we want both the entities on both sides to be involved in the relation here, to be involved in the foreign key here, the relation indicated by the foreign key here. We want data on both sides to satisfy this condition here. So we need an inner join to enforce this. Because inner join provides match on both sides, so it's the most strict type of join. So what we can do is we can select from employees we can omit the keyword inner there in this case. Join departments. We need to select the attributes. We need to select employees dot employee name and departments dot department name from the joined tuples, and we need to specify the condition because we want to find out the associated department of that employee. We don't just want to randomly attach departments to employees. So what we can do is we need to specify the on condition here. So we need to specify that employee works in that or belongs to that department. Sorry. So this is what we can eventually get. We can select from So we can select the employee name and the department name from a set of joined or combined tuples. By the tuples from the table of department is attached to the tuple from the employee table, if and only if the belongs to attribute of that employee table equals to the department ID from the department's table. And this will give us the result for our first question. So as you can see, we have a pair of attributes listing the employee and the department they are working in. And do note that for computer science and engineering, it doesn't appear in this in the result because it is not, this department doesn't have any employee. And for E1, and this guy is not in our result because he's not associated with any department. So this is the answer to our first question here. What about the second one? Let's try to find all employees, including those without a department. Let's say we want to follow the order of the tables here. We want to specify the table employee first, and then specify the table for department first. So which type of drawing should we use here? Yes, left, right. And because the reason is that we want to find all employees, even for those without a department. So for left drawing, all the rows inside the left table are put into the result, even if there's no match on the right table. So let's see the result here. Actually, it's the same as left outer drawing, but we can just omit the outer keyword there, and let's see what's the difference. As you can see, E1, the employee who's not associated with any department, is now in our result, and you could also notice that the value, since it doesn't have a match in the department table, the default value is set to be null in the returned result of our select. So this is the third question. This is the second question. What about the third one? Let's try to find all departments, including those without any employees. So what's the type of drawing we should use? It's simple, right? It's right drawing. So because we want to find all departments, even if that department doesn't have any employee. For example, for computer science and engineering, this department doesn't have any employee, and we still want it to appear in the result. What we can do is we just use the right drawing. Since, please do notice that the ordering of tables matter here. So if we still want to use left drawing, let's try to stay with left drawing. So what we can do is we need to change the ordering of the tables here. So we can either change the drawing from left to right, or we change the order of the two tables. So they will give us the same result. So as you can see, I just ignore this. As you can see, computer science and engineering appears in the result. So it is the same as, because we only have two tables here, it is the same as we change it to right drawing, and we change the ordering of the two tables. It will give us the same result. Let's see. As you can see, we will still have the same result. So this is about left and right drawing. So for our last question, so list all employees and departments, including those employees without a department and the department with no employees. So which type of join should we use? Actually, there's only one left, and that is full outer join. So what we can do is we can just do a full outer join, and let's see what it will give us. So we can omit the keyword outer here again, and let's run it. As you can see, both Ivan, who doesn't have a department, and computer science and engineering, which doesn't have any employees, are in our result. And the order doesn't matter here. If we change the ordering of the tables, we will still get the same result. Oh, sorry. I just deleted the full. We will still get the same result. So for full join and inner join, the ordering of table doesn't matter. But for left join or right join, you should be careful about the ordering of the table names. And that's the examples of all the different types of joins we have learned. And you may wonder, how does DBMS implement the join operators? So this is a pseudocode for implementing join. So let's say we only have two relations involved. So we will have two loops. The outer loop will iterate through the first relation. The inner loop will iterate through the second relation. And we will apply the condition checks which are specified by the on keyword there inside the inner loop. So what if we want to add more relations into this join? So we will add another layer of loop. So we will add a third layer of loop. So it's very easy to add more relations. And what if we want to add more conditions? We can just add more conditions in the innermost loop. So this is not exactly how DBMS implement the join mechanism, because they do some they have some optimization mechanism to speed up this process. However, as you can see here, the more table you join together, the more cost it will incur for this operation. Actually, in practice, you should be careful when you use join operators. If you join several large tables, you will see that the computational cost or the computational complexity will grow drastically. So that's why you should be careful about using joins, especially the outer joins. You will get a lot of you may spend a lot. The SQL server may spend a very long time to handle a join statement. And you may notice that sometimes different tables, they could have the attribute with the same name. So how do we deal with the clashes of names? And in our previous exercise we have done just now, you may notice that when we write the select query, we could use the table name dot attribute name to uniquely identify the attribute. So that's how we do this, deal with the name clashes. So what we can do is we can use the table dot attribute to uniquely specify an attribute. Or alternatively, because SQL queries allows us to do renaming, we can rename our tables. We can create aliases for the tables. What we can do is we can, when we select from a table, we can append a space plus an alias for that table, and that gives us a unique name for the table, and we can use oops, there's an error in this relationship here. So we can use the alias of a table to represent that table as well. So we can create so-called names for tables. So this is useful, especially when you are joining a lot of tables, and the table names are very long. So it will make your code more readable. So this is how we deal with name clashes. And just now we discussed we can use table dot attribute to uniquely specify an attribute. However, it doesn't help if we use the same table twice in select. So in this case, we can create a different alias for each instance of that table. So you may wonder, why do we need to join two tables together? Why do we need to use a single table twice in one query? So here's an example. For example, we have for the employee table, how do we find pairs of employees with the same family name? We need to use the employee table to join itself to form pairs of tuples, right? If we want to have pairs of tuples, we have to join two tables together. And in this case, the two tables are referring to the same table, to the employee table. So in this example here, we need to join the two instances of employee table together. And we can't simply use employee.zid and employee.zid because is causing confusion to the system. So what we need to do is we need to specify a unique alias for each instance of the table here. So in this case, for the first instance of employees table, we name it as E1. For the second instance of the same table, we name it as E2. And we select, since we are generating pairs of employees, so we select the ZID for the first employee, we select the ZID of the second employee, and then we join them together on the condition that they have the same family name. So that's how we do this. That's how we do how we deal with using the same table twice in one statement. And you may notice that there's a where condition here. So this where condition is actually very helpful for handling two cases. So since an employee must have the same family name as he or herself, so this is, if we use an inequality which is smaller than here operator, we can avoid pairing the employee with that employee, he or herself. So that's the first usage here. The second purpose of using this where condition is that sometimes because we are running the same table twice, we may have duplicate data with different orders. So AB or BA, they are joined together. As far as they have the same family name, they will appear twice. And this smaller than here can help to remove the same pairs with different orders. So this is this is how we deal with how we deal with using the same table twice in one statement. And this is just a small trick, and you don't have to worry about that. And what you will need to remember here is just that when you use the same table twice, you give each instance a unique alias, and that's it. So you may use the same table for 3 times or 4 times, but every time you use it, you give that instance a specific alias, and that's the thing you should remember here. This here is just a trick. And that's all for today's lecture. Don't forget to do your quiz and stay updated for the information of your assignment 1. And thank you. You don't have access to what?
I don't have access to the lectures.
Why?
Because I couldn't manage to enroll this term, but I wanted to learn.
I see.
So could you perhaps share me the link?
Do you have friends who's enrolled in this course?
I'm enrolled next term, but I couldn't get it this term.
Oh, I see. You can send me an email. You know my email address, right? Or maybe you can take a photo. You can send me an email and I will send you the list of the slides.
Thank you.
No worries. No, you can't reuse it across different statements. It's only within that statement.